Alright, let's take a look at some things that I would be able to do if I was taking the final exam on Monday. I would certainly know the difference between the types of Riemann sums. For example, if we had a graph that looked kind of like this, and we broke it into intervals like that, and we're coming from the right-hand side, that's a right-hand sum. Now, if we took a graph that looked similar, and this time we came from the left, that's a left-hand sum. Okay. I don't like that graph. There's also a midpoint sum, right? And let's not forget the ever popular trapezoidal sum. Here we'd make trapezoids like this. Okay, so I would know the differences between those. I would be able to integrate something like 3x squared plus the square root of x dx. First thing I would do here is write the square root of x to the 1/2, and then find the antiderivative. Antiderivative of 3x squared is x cubed. X, I add 1 to the exponent and I get 3/2, multiply by the reciprocal, I get 2/3, and I add the c at the end. Let's see, what else would I be looking at? I think I would be able to integrate something like the 4th root of 3x minus 7 dx. So what I'm going to do here is I'm going to let u equal 3x minus 7, and that makes du equal 3 dx, or 1/3 du equals dx. And now what I can do is rewrite this integral 1/3 times the integral of u, and instead of writing it 1 over the 4th root, I can raise that to the 1/4 power du. So now 1/3 comes along, I add 1 to the exponent and I get 5/4. I multiply by the reciprocal, that's 4/5. I add c, so 1/3 times 4/5 is 4/15. Substitute back in for u, 3x minus 7 to the 5/4 plus c. Alright. Now let's see, what else would I be able to do? I would be able to find the antiderivative of x times the cosine of x squared dx. I got x squared as the innermost function, so I'm going to let u equal that. U equals x squared, so du equals 2x dx. Well, there's an x and there's a dx. Move the 2 to the other side, 1/2 du equals x dx. Now this thing can be rewritten as 1/2 times the integral cosine of u du. Well, that's 1/2 antiderivative of cosine is sine of u plus c. So that becomes 1/2 times the sine of x squared plus c. Alright, now, if I came across something that looked like this, alright, I can see many people going, oh my gosh, what am I going to do with this? What am I going to let u equal? How am I going to do that? Well, before we start to panic, let's do a little work inside that integrand. 5x times 2x to the 4th is 10x to the 5th, minus 7 times 5 is 35x dx. And now we can find the antiderivative of each individual piece. X to the 5th, add 1 is x to the 6th, and multiply that becomes 10 over 6 minus 35x, I add 1 there, I get x squared, multiply by 1 over 2, so I get 10 over 6 x to the 6 minus 35 over 2 x squared plus c. And if you really want to reduce these things, you can get, what are we going to have, 1.8 x to the 6th minus 17.5 x squared plus c. That is absolutely acceptable. Oh, let's see, what else would I know how to do? If I had something like the integral of the tangent of x times the secant squared of x dx, I would be sure to look at that and think to myself, ooh, I've got the tangent. If I take the derivative of the tangent, I get secant squared. Now, that makes this integral become the integral of u du, which is 1/2 u squared plus c, which is 1/2 times the tangent squared of x plus c. Let's see, what else? If I was told that f of 0 equals 2 and that f prime equaled 2x plus 3, and that I was supposed to find f of x, I would look at this and realize, well, if this is the derivative of f of x, then what I need to do is find the antiderivative. And that's going to be x squared plus 3x plus c. And now let's see. I know that f of 0 equals 2. So that's 0 squared plus 3 times 0 plus c equals 2. So c equals 2. So that tells me that f of x is equal to x squared plus 3x plus 2. If I was looking at a graph comprised of line segments, okay, I would realize or hope that, or I would know, that when you're below the x-axis, that's negative area. And when you're above the x-axis, That's positive area. Okay. So if I was asked to estimate this integral from a to b, I would realize that it would be the blue area minus the red area. Okay. If I was looking at a graph and was asked some questions about limits and continuity, I would look at this and realize that it is continuous and the limit exists here. I would realize that the limit exists, but it's not continuous at that point. I would look over here and see that the limit does not exist and it's not continuous there. Okay, and those are things I would know. More things. If I was asked to evaluate the limit as x approaches 3 of x squared minus 9 over x minus 3, I would look at that and I would think to myself, that I could factor that numerator and I could get the big giant 1 right here. And then if I let x approach 3, we see that equals 6. Now, if we think all the way back to pre-calc, we would realize that this was a whole because we can cancel that out, and the whole then would be at 0, 6, and that's what the limit is equal to. Now, if we change that a little bit, limit as x approaches 3 of x squared plus 16.
Would Kara Hutchinson please call extension 1105? Kara, please call 1105.
We get x squared plus 9 over x minus 3. This limit does not exist, right? Because this becomes 18 over 0. That limit does not exist. Another one, don't let this one confuse you, the limit as x approaches 4 of x squared minus 9 over x plus 3. I don't want a 4 down here. I want a 3 right there. Realize that this is 0. 9 squared minus 9 is 0. 3 plus 3 is 6. 0 over 6 is still 0. Alright. Let's see. I would be able to take the derivative of something like x cubed times the cubed root of 2x minus 3. And I would hope that we would rewrite that right away. X cubed times 2x minus 3 to the 1/3 power. And we got to use product rule here. So this becomes 3x squared times 2x minus 3 to the 1/3. And then we leave the x cubed alone. And we've got times 1/3 times 2x minus 3. 1/3 minus 1 is negative 2/3. Now we take the derivative of what's inside and we get 2. And there we have the derivative. I would definitely be able to use quotient rule if I had something like y equals the sine of x over 3x minus 4. Y prime is ho. D high, derivative of sine is cosine, minus high. D ho, derivative of 3x minus 4 is 3, and that's all over ho ho. squared. Alright, so I'd be able to do that. What else? If I gave you something like f of x equals the sine of 2x, and I told you that x was going to equal pi over 3. Now let's do pi over 6, it'll be easier. And I said to write the equation of the tangent line to f of x when x equals pi over 6. Well, we need a point in the slope. So the first thing I'm going to do is I'm going to find f of pi over 6, which becomes the sine of 2 pi over 6. And the sine of 2 pi over 6 is pi over 3. Sine of pi over 3 is the square root of 3 over 2. Okay. Now, so we've got the point pi over 6 square root of 3 over 2. Now what we need is a slope. F prime of x, the derivative of sine is cosine of 2x, times the derivative of 2x, which is 2. Well, the f prime, or f prime of pi over 6, if we want to think about that, is the cosine of 2 pi over 6 times 2. Cosine 2 pi over 6, cosine pi over 3 is 1/2 times 2 is 1. So, y minus the square root of 3 over 2 equals x minus pi over 6. And if you want to go times 1, that's fine. You can leave it just like that too. That would get you the equation of the line. If you really like slope-intercept form, y is going to equal x minus, what's this going to end up being? Pi plus pi over 6 plus the square root of 3 over 2, which is going to end up being x minus pi plus 3 square roots of 2 over 2. But, in all honesty, if you can get it like that, that's where I would write it, that's where I would leave it. All you can do over here is make mistakes. Let's see, what else? I would make sure that I could do some implicit differentiation. And what is implicit differentiation, you may ask? Something like negative x cubed y squared plus 2xy plus 3x squared y cubed equals 7. And implicit differentiation is we would take something like this and solve for y prime or dy dx. Remember, dy dx is just another way to write y prime. And it's not always a bad idea to write that on your paper. Negative 3x squared y squared plus, minus 2x cubed y prime. Remember, because we don't know what y is, we know it's some function of x, but we got to remember the chain rule. Derivative of y is y prime, plus 2y plus 2x y prime plus, I made this too long, plus, let's see, 6x y squared plus 6x squared y prime, all of that equals 0. Okay. Now, I'm going to get everything that has a y prime in it on one side of the equal sign and everything that doesn't have a y prime in it on the other. And let's see if we can move some of this up. So, negative 2x cubed y prime plus 2xy prime plus 6x to the 7th y prime equals negative 3x squared y squared plus 2y plus 6xy squared. Now, I've got a y prime here, and here, and here. So y prime is going to equal, I'm going to do this all in one step, negative 3x squared y squared plus 2y plus 6xy squared over negative 2x cubed y plus 2x plus 6x to the 7th. No, that should be x squared. X squared y. Okay. And if you can do all of that, you will be in great shape.